Hello, everybody. I'm Rafael Ortega, and with Raquel Marcos, we lead RAEL Arquitectura, which focuses exclusively on passive house projects. I would like to say that we're delighted to be speakers at this 12th Spanish Passive House Conference and of having been organizers despite the current coronavirus crisis. At least as it is a virtual paper, we're giving it from the building that we're talking about. We're talking about the R&Roll houses, the first Passivhaus Plus certified buildings in the Spanish Mediterranean area. They have been monitored with different parameters and for different reasons. Firstly, because we wanted to understand better the behavior of these types of buildings in the Mediterranean climate, and to obtain more information to passive house designers. Also to compare forecasts with the PHPP tool. And finally, to quantify the possibilities and advantages to convince these skeptical individuals. And with no further ado, we're going to proceed to show you the project. The buildings are in the north of Valencia, at Rafael Buñol, 6 kilometers from the beach and 21 meters above sea level. The climate is typically Mediterranean, with mild winters, warm summers, and rain concentrated in spring and autumn. The relative humidity throughout the year is quite high. So we need to control it within the buildings to have the adequate comfort criteria. The winds are of medium intensity and come from southwest, from the sea, which allows us to lower temperatures during summer nights. So we've used passive measures to design this project that favor cross-ventilation in this direction in the main rooms. As you can see, if you study the average annual temperature in Valencia for the past 10 years, we can see that there has been an increase of 0.7 degrees with respect to previous decades, and the data are worse than the ones we have observed worldwide. So it indicates that in the Mediterranean, the standard passive measures have to take this more into account in the global context of climate change. The R&Roll houses are two single-family homes between party walls with an outer yard looking east that you can enjoy all the year round. The homes are distributed with the day area on the ground floor, with a living room and kitchen overlooking the yard and a small toilet, and the garage outside the thermal envelope. And the night area is on the first floor with 4 bedrooms and 2 fully equipped bathrooms. In the upper floor, there is a studio and a place for the typical installations of a passive house. The windows are large, particularly in the southwestern side, to make the most of solar energy in the coldest time of the year. That's why it's essential to avoid overheating during the summer. For this purpose, we tried to bring together all the sun protections under domotic control in all areas. And as far as the passive house features of the building, the thermal envelope has been carried out with an SAT system with 120 millimeter rock wool. The windows are aluminium on subframes of wood conglomerate and triple glazing. All the windows have domotic sun protection systems to avoid overheating in the buildings during the summer. For airtightness, we have used a vapor barrier and plaster. And with respect to installations, the buildings have mechanical ventilation with heat recovery and passive house certification. We've also installed an aerothermal heating pump for heating, climate control, and domestic hot water. The buildings also receive the energy they need from the PV installation that we have on the roof and with the pumping of the surplus to the grid. Apart from passive house installations, we have reduced the consumption of a scarce resource in the area, which is water. And we have equipped the buildings with a grey water recovery system, with taps with a low consumption level and domestic hot water recirculation system in all the area. And we've also carried out a free design of electromagnetic fields in the most important rooms. You can see here the most important certification data. We see that we have similar data for cooling and heating, with values around 10.5 kilowatts hour square meter year. And I'd also like to say that we carried out global certification of the buildings with a thermal envelope and 2 airtight envelopes. As far as the methodology used, all the relevant parameters have been monitored to quantify the advantages of this type of building. Quantification of temperature, CO2 levels, and relative humidity have allowed us to assess comfort and validate how good these buildings are also in the Mediterranean climate. But we've also analyzed other parameters, those related to health, such as measuring the levels of formaldehydes, of COPs, electromagnetic fields, and radiation levels, and also parameters that are sustainability related. We've analyzed the necessary consumption for the operation of the buildings, not only related to interior water and the production of hot domestic water, but also the PV energy produced. And we've also measured the amount of water that we have saved thanks to the measures implemented. The most in-depth monitoring has been done in one of the buildings, and the data that we're going to show you refer to this one. However, to verify certain aspects, we've also taken specific measurements in the other building so that we could have concluding data, because we're talking about the same buildings in the same weather conditions. Monitoring was carried out in August 2019 until July 2020. To study comfort and health parameters, we took measurements in the living room and main rooms. And we have installed sensors to do this, to measure comfort and energy consumption. The first graph tells us interior temperature values and exterior temperature values for last year, and we see they remain stable during the year with interior temperatures of 20 degrees in winter and 25 in summer. On the high growth thermal comfort chart, we can see that we have comfort conditions all the year round, with the exception of the summer and winter holidays. This chart shows us the indoor and outdoor relative humidity throughout the year. The relative humidity is between 40 and 70% indoors. And it's important to highlight that the humidity conditions of where the homes are close to the sea and typical of the Mediterranean climate means that regulating the humidity has been more than enough in the building to keep optimal values of relative humidity the year round. In this graph, we show the CO2 concentration values throughout the year, and we can see that we never go above 1,000 ppms. When we talk about heating demand, on this PHPP chart, the theoretical demand happens between November to March. Though, as you can see in the actual consumption chart, there's been a very small demand between December and February. And this demand has been lower than the data obtained in theoretical calculations. The theoretical contribution of cooling happened during the summer, July and August, but in actual life, the period has been much longer. We're talking about the stretch between May and October. But just like in the previous case, the registered values, the total registered values, are lower than the ones provided for and forecasted by the PHPP. When it comes to the data obtained from the monitoring during the first year, we've compared these data to the theoretical data calculated, verifying that the actual demand for heating has been 182 lower than the data calculated with the PHPP tool. We can also see that during the previous year, temperatures were higher during the winter as a result of global climate change. And as you can see, this year's values that appear in black are higher than the ones we considered in the theoretical calculations that appear in red. So we have adjusted the sensitivity of the calculations, introducing the actual values of temperature that have been registered during the period studied. So the corrected value is lower than the initial one. But even with these adjustments, the actual demand for heating is under the theoretically adjusted one in 75%. And we've also corrected the actual consumption data, comparing them to the consumption that has not taken place during the holidays. So with all the corrections and adjustments, we see that there's a weighted actual consumption that is much lower than the theoretical one, specifically 69% lower. And when we talk about the demand for cooling, we have seen that the actual consumption has been 52% less than the theoretical calculations. Just like in the previous case, we have adjusted the theoretical data and updated them with the actual temperature values of the previous year. And the corrected values in this case for cooling have been higher than the initial one due to temperature increase. So actual consumption has been 56% lower than the corrected theoretical value. So the progressive increase of temperatures means that in the Mediterranean climate we have to make a greater cooling effect in order to achieve comfort levels. We've also corrected the actual consumption data, including the summer holidays. So the weighted actual consumption is 38% lower than the theoretical corrected values. Of all the data collected from cooling and heating, we have to point out the following conclusions. On one hand, we have seen that PHPP is a trustworthy calculation tool with safety margins that allow us to design passive houses with the assurance that they're going to work. However, we think that it's also extremely important to make sensitivity adjustments of climate data to fine-tune our results and calculations. On the other hand, in the Mediterranean, we need to control solar radiation during the summer with active and passive methods that will avoid overheating. And finally, it's important to point out that it is crucial for the user to be an active element and be trained to make the most of a passive home throughout the year, using it adequately. So to this end, the R and roll houses have become a test lab to analyze the influence of trained user in reducing energy consumption and maintaining adequate comfort levels. Because as we have two buildings with the same orientation, that are the same, and that are being monitored during the same period of time, it has allowed us to see the effect of a well-trained user in one building with a proactive attitude towards passive measures for sun protection and night cooling, whereas in the other building we had a user that wasn't well trained to adopt these measures, and we compared the consumption during the same periods of time. So, with the same setting temperature for the climate control system, and to give an idea of the influence of the use in this process, it's important to note that there was a consumption difference of up to 27% in summer. So it has been proven that it is vital to also make efforts in training future users of our buildings. This way they will be able to make the most of the passive measures available, and we avoid undesirable operations that will lead to bad practices. We should make the most of passive buildings with active users. This graph shows the total annual electricity consumption of the building. And the electric energy produced by the PV installation that was higher than expected in the calculations. The use of solar energy means that CO2 emissions have lowered considerably. But what is more important is that the building becomes a positive passive house, producing more energy than they need throughout the year. Finally, just to give you an idea of other parameters that we've studied. We worked with the impact of radiation on the buildings, and we minimized them with corrective measures. We carried out measurements before and after, and we always obtained values under the thresholds recommended. With respect to the quality of the indoor air, we worked with natural products with low toxicity levels, and we can see that the level of formaldehydes and others is low. In fact, you can see the levels during the holidays, where we saw peaks of days where the building had occupants, and we have to point out that the use of disinfectants and hydroalcoholic sterilizing gels mean that the concentration of formaldehyde goes up very, very fast and to very high levels. So it is vital to understand the role played by mechanical ventilation to lower these levels as much as possible. For water consumption, we have measured the savings throughout the year, combining the effect of recirculation of hot domestic water using aerothermal EcoSmart aerators, and the amount of liters per year saved has been 107,300 meters per building, which gives you an idea of the water saving potential that our buildings can have and how important it is for dry areas. Therefore, in this project, we have shown you that the passive house concept is applicable with all its advantages to the Mediterranean climate, also proving that the actual operation of the home with well-trained users improves the forecast of PHPP calculations, reducing consumption levels and maintaining comfortable conditions indoors. And with this, I would like to conclude my presentation. So thank you very much for your attention, and it will be a pleasure to reply to any questions you may have. Thank you, and see you later.